Miscellaneous exercise of chapter 7. Question number 1.
How many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word daughter? In this word daughter, we have 8 alphabets. A, U, E. 3 vowels are there. And consonants, 5. Now out of these 3 vowels, we have to select 2 vowels and we have to select 3 consonants. First we will do the selection and then we will put all these selected 5 letters together and arrange them. So first selection is done and then put them together and arrange. What happens if we arrange at the beginning itself? If I write 3P2 times 5P3, that is 2 vowels are selected and arranged, 3 consonants are selected and arranged. Okay, but this is wrong because in this answer the vowels are together and 3 consonants are together. The question doesn't say like that. Okay, so we can mix up vowels and consonants. Therefore, this method is wrong. So what we should do is, we will do the selection first. Mix them up. Put all 5 selected letters together, vowels and consonants. 5 letters are there. Now 5 letters we can arrange in 5 factorial ways. 2 vowels can be selected in 3C2 ways and 3 consonants can be selected in 5C3 ways. The selected 5 letters can be arranged in 5P5 ways. 5P5 is 5 factorial, which is 120 ways. Therefore, total number of ways is equal to, we have to select 2 vowels and we have to select 3 consonants out of 5 consonants and we have to arrange all 5 selected letters. So it is and. We need to multiply. Let us simplify this answer. 3C2 is 3. 5C3. If I cancel 3 factorial, it becomes 4 times 5 divided by 2 factorial, which is 2 times 120. Sixty times 60. The answer is 3600. Question number 2. How many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants occur together? So underline these words in the textbook. Vowels and consonants occur together. This condition was not there in the previous question. That's why we had to select first and then put all the selected letters together and arrange. Now the word given is equation. We have 8 different letters in this. And vowels, 5 vowels are there. And consonants, the remaining letters are consonants. 3. We have to use all the letters of the word equation. All 5 vowels and all 3 consonants should be used. We can put vowels together first. 5 vowels together and then 3 consonants can be written. arranged, or we can put 3 consonants first and then 5 vowels. So 2 ways are there to arrange. So 5 vowels can be arranged in 5p5 ways, which is 5 factorial, 120 ways, and 3 consonants can be arranged in 3p3, which is 3 factorial. 3 factorial is 6. So consonants can be arranged in 6 ways. And to arrange vowels and consonants or consonants and vowels, we have 2 ways. Therefore, total number of ways is equal to, in which vowels and consonants occur together, is equal to 5 factorial, that is 120 times 6 times 2. 12 12s are 144 and 0. 1440 is the answer. Question 3. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls, at least 3 girls, and at most 3 girls? Let us do the first subdivision. We have 9 boys and 4 girls. A committee of 7 has to be formed. And exactly 3 girls we should select. Exactly 3. So if I select 3 girls, the committee should have 7 members. So 7 minus 3, 4 boys we have to select. Therefore, number of ways is equal to, this is a very simple question. It is a selection question, so combinations we have to use. 9C4 and, so multiply it with 4C3. So 4 boys can be selected in 9C4 ways and 3 girls can be selected in 4C3 ways. We need 3 girls and 4 boys, so multiply. Let us simplify this. 9 factorial divided by 4 factorial times 5 factorial, and 4 factorial divided by 3 factorial, and 4 minus 3 is 1 factorial. Cancel 5 factorial from 9 factorial. 6, 7, 8 and 9. 3 factorial is 2 times 3. 7 times 72, which is 504. Second subdivision, at least 3 girls. We have 9 boys and 4 girls. So the word at least is important. Underline this word in the textbook. So what do you mean by at least 3 girls? Minimum 3 girls. So we may select 3 girls or 4 girls. We cannot select more than 4 because only 4 girls are there. So we have 2 cases here. If I select 3 girls, I have to select the remaining 4 boys. Or, here we use or. We may do the selection like this. We may select 4 girls and 3 boys. So totally 7 members will be there. Here we use and. We need 4 boys and 3 girls. Or 3 boys and 4 girls. So total number of ways, I am writing the answer directly. You write the steps and then add. So total number of ways will be
9C4 into 4C3 plus 9C3 into 4C4.
Let's simplify this answer. This first answer we calculated in the first subdivision, which is 504 plus 9C3. 9 factorial divided by 3 factorial times 6 factorial into 4C4 is 1. 504 plus cancel 6 factorial, 7, 8, 9 divided by 3 factorial. 504 plus 84. The answer is 588. Third subdivision, at most 3 girls. Underline the word at most. At most 3 girls means maximum 3 girls. So maximum 3 girls is we may select 3 girls or 2 girls or 1 or 0 girls. So we have 4 cases. Out of 9 boys and 4 girls, the first case, select 3 girls, remaining 4 boys should be selected out of 9, or select 2 girls, the remaining 7 minus 2, 5 boys we have to select. The third case, select 1 girl, 7 minus 1, 6 boys we have to select, or if we select 0 girls, we have to select all 7 boys. Here we have and 4 boys and 3 girls, or 5 boys and 2 girls, or 6 boys and 1 girl, or 7 boys and 0 girls. So total number of ways is equal to, it is only a selection question, combination question, 9C 4 times 4C3, first case, or 9C 5 times 4C2 plus 9C 6 times 4C1 plus 9C7 times 4C0. The first answer is 504. 9C5 and 9C4 are same. So if I cancel 5 factorial, 6, 7, 8 and 9 divided by 4 factorial, 2, 3, 4. 4C2, 4 factorial by 2 factorial into 2 factorial, cancel 2 factorial and denominator has 2. 9C6, 9 factorial by 6 factorial into 3 factorial, cancel 6 factorial, 7, 8, 9 divided by 3 factorial is 2 times 3, 4C1 is 4. And then the last term, 9C7, 9 factorial by 7 factorial into 2 factorial. Cancel 7 factorial, 8 times 9 by 2 and 4C0 is 1. And the second term is 756 plus 56 times 6, 336. And then the last term, 4 9s are 36. Add these 4 numbers. The answer is 1632. Question number 4. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? The word given is examination. Which has 11 alphabets. Out of these 11 alphabets, we have A 2 times, I 2 times, we have identical letters, N is also 2 times, and all other letters are appearing only once. Now, as in dictionary order, we have to arrange. We have 11 alphabets to arrange, and as in dictionary order means we will calculate first how many words can be formed starting with the letter A. So A is fixed in the first position. Now remaining 10 alphabets I have to arrange. which can be done in 10 factorial divided by, out of these 10 alphabets, I have 2 I's and 2 N's. I don't have 2 A's because 1 A has been fixed in the first position. So in the remaining 10 alphabets, I will have only 1 A. This 2 factorial is for 2 I's and this 2 factorial is for 2 N's. Out of these 10 alphabets, we have only 1 A, not 2 A's. Fixing A in the first position. Remaining 10 letters can be arranged in 10 factorial divided by 2 factorial times 2 factorial, which is equal to, if I cancel 2 factorial, we get 3, 4, 5, 6, 7, 8, 9 and 10 divided by 2. The answer is 907200.
As per the dictionary order, the next word should start with E.
But the question is before the first word starting with E. That means only starting with A we can count. So the answer is 907200. Question 5. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9 which are divisible by 10 and no digit is repeated? So the first condition given is we have to form a 6-digit number. The second condition given is we have to make use of these digits 0, 1, 3, 5, 7 and 9. The third condition is it should be divisible by 10. And fourth condition is no digit is repeated. Now you have to consider all these 4 conditions and calculate. We have to form a 6-digit number and it should be divisible by 10. So divisible by 10 means it should end with 0. So fix 0 in this last position, units place. Units place should be 0. Then only it will be divisible by 10. Okay, now remaining 5 positions we have to fill in. And totally 6 digits are given. Already 0 has been fixed in the units place digit. We have remaining 5 digits only. Out of these 6 digits, 0 has been used. Now we have remaining 5 digits. So 5 places remaining. 5 digits in 5 places can be arranged in 5p 5 ways. Remaining 5 digits can be arranged. It is an arrangement question, permutation question. 5p 5 ways. Which is 5 factorial. The answer is 120. Into 1 you will get for the units place. So the answer is 120. Question number 6. The English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So it is similar to that first question. Totally we have 5 vowels and 21 consonants, out of which we have to select 2 vowels and select 2 consonants, put them together
and arrange the selected 4 alphabets.
We cannot arrange at the beginning itself, because if I write 5p2 times 21p2, that means vowels and consonants are together. The question doesn't say like that. So we will do the selection first. We will select 2 vowels and we will select 2 consonants, and totally we will have 4 alphabets, and we will arrange these 4 selected alphabets. So 2 vowels can be selected out of 5 vowels in 5C2 ways, and 2 consonants can be selected out of 21 consonants in 21C2 ways. And totally we have 4 alphabets, the selected 4 alphabets. So 4 alphabets can be arranged in now comes the arrangement. 4P4 ways, that is 4 factorial ways. Therefore, total number of ways is equal to, so since we don't have the condition of vowels and consonants being together, we will do the selection of them first and then we will arrange the selected alphabets. 5 factorial divided by 2 factorial times 3 factorial. This is 21 factorial divided by 2 factorial times 19 factorial, and 4 factorial 24. 4 times 5 by 2, 20 times 21 divided by 2 multiplied by 24. 100 into 21 into 24. The answer is 50400. Question 7. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2, containing 5 and 7 questions respectively. Totally 12 questions are there, divided into 2 parts, part 1 and part 2. Part 1 has 5 questions and part 2 has 7 questions. A student is required to attempt 8 questions in all, selecting at least 3. So first condition is totally 8 questions should be selected. The second condition is at least 3 should be selected from each part. In how many ways can a student select the questions? So at least 3. What do you mean by at least 3? Minimum 3. In case the student selects 3 questions from part 1, totally he has to attempt 8 questions. So 5 he has to select from part 2 to make it 8. And then if 4 questions are selected from part 1, then remaining 4 questions are selected from part 2. Or if 5 are selected from part 1, the student has to select 3 from part 2. And we have and here. So let us write the total number of ways. 5C3 times 7C5, or the selection may be 4 and 4. So 5C4 times 7C4, or 5C5 times 7C3. 5C3, 4 times 5 by 2, 6 and 7 by 2 factorial. You write the formula and then simplify. 5C4 is 5. 7C4 and 7C3 are same. So 4 factorial. 5, 6, 7 divided by 3 factorial. 5C5 is 1. 7C3. 5, 6, 7 divided by 3 factorial. The first answer is 210 plus 175 and plus 35. The total is 420. Question 8. Determine the number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards has exactly 1 king. So totally we have 52 cards in a pack. Something about king card is mentioned in the question. So we will group this pack as kings and non-kings. How many king cards are there in a pack? 4. Non-kings 52 minus 4, which is 48. Now totally 5 cards we have to select. Each selection of 5 cards has exactly 1 king. So 1 king from this group we have to select, and the remaining 4 cards we have to select from non-kings group. Therefore total number of ways is equal to, it is a only selection question, so 4C1 and 48C4. 4C1 is 4. This is 48 factorial divided by 4 factorial times 44 factorial. 44 factorial could be cancelled. 4 factorial is 2, 3 and 4. "45 times 8 is 360 and 46 times 47 is 2162. The final answer is 778320. Ninth question. It is required to seat 5 men and 4 women in a row so that the women occupy even places. So we have a condition for ladies. How many such arrangements are possible? So totally we have to arrange 9 people. So we have 9 seats available. 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the condition for women. Women occupy the even places. Second position, fourth position, sixth position, eighth position. 4 women are there, only 4 even places are there. So in how many ways I can arrange these 4 ladies in these 4 positions? 4p4. So 4 women in 4 even places can be arranged. It is an arrangement question, permutation question, in 4p4 ways, which is 4 factorial ways. Okay, now remaining we have 5 positions and 5 men. I can arrange 5 men in these 5 positions, 1, 2, 3, 4 and 5. So 5 men in the remaining 5 positions can be arranged in 5p5 arrangement. It is a permutation question. So 5p5 is 5 factorial ways. We have to arrange the 4 women and 4 men. Therefore, total number of ways is equal to 4 factorial times 5 factorial, because it is AND. 4 factorial is 24, 5 factorial is 120. The answer is 2880. Question number 10. From a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. In how many ways can the excursion party be chosen? Totally we have 25 students. 10 are to be chosen for the excursion party. There are 3 students. So we will group them. We will take these 3 separately, the remaining 22 students here. So there is a condition. These 3 students, they say that either all of them will join or none of them will join. These are the 2 cases. If all 3 are joining, totally we have to select 10. If all 3 are joining, I have to select only remaining 7 people out of 22. Second case, if none of them are joining, I have to select all 10 out of 22. These are the 2 cases. And here we have OR. We may do the selection as 3 and 7 or 0 and 10. Therefore, total number of ways is equal to, it is only selection, combination question. So 3C3 times 22C7, or the selection may be done like this, 3C0 and 22C10. 3C3 is 1, 22C7 plus 3C0 is also 1, 22C10. It's a big number, so let us leave the answer in this form. Question number 11. In how many ways can the letters of the word assassination be arranged so that all the S are together? Thirteen alphabets are there, and out of these 13, we have 3 A's, 4 S, 2 I's, and 2 N's. Identical alphabets we have. Now the question is, so that all S are together. We know how to do together questions. We will put all 4 S and count them as one alphabet. Writing the remaining alphabets, A, I, N, A, T, I, O, N. So let us count the alphabets. Count this as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now we have to arrange 10 alphabets, counting S as 1. So 4S is taken as a single letter. Therefore, number of ways is equal to, so 10 alphabets can be arranged in 10 factorial ways. Now out of these 10 alphabets, we have 3 A's and 2 I's and 2 N's. Don't divide by 4S because we have taken 4S as one alphabet only. And these 4 S which are together can be arranged among themselves in only 4 factorial by 4 factorial ways, which is one way only. So into 1. Therefore the answer is 10 factorial divided by 3 factorial into 2 factorial into 2 factorial. Cancel 3 factorial. Five, 6 are 30. 72 times 7. 504 into 10. Therefore the answer is 0, 0, 2 1 5 1 1 5 1 2 0 0. Example 20. How many words with or without meaning, each of 3 vowels and 2 consonants, can be formed from the letters of the word involute? Totally 8 alphabets are there. All 8 alphabets are different here. And vowels, and consonants, 4. Now out of this we have to select 3 vowels, 2 consonants, and we have to arrange. And in this question also, it is not mentioned that consonants should be together or vowels should be together. So we will do the selection first and then we will arrange. So total number of ways is equal to, so first we are selecting 3 vowels out of 4 vowels and 2 consonants out of 4 consonants. Since we are doing selection, I am using combination 4C3 times 4C2. And totally we have 5 alphabets to arrange. Now 5 alphabets can be arranged in 5p, 5 ways, which is 5 factorial. 4C3 is 4 and 4C2 is 3 times 4 by 2 and 5 factorial is 120. The answer is 2880. Example 21. A group consists of 4 girls and 7 boys. In how many ways can a team of 5 members be selected if the team has no girl? No girl. That means all 5 are boys. It is only a selection question. So number of ways is equal to, very simple question, 7C5, 5 factorial, if I cancel 6 times 7 by 2 factorial. The answer is 21. Second subdivision. In the second subdivision, at least 1 boy and 1 girl. Underline the word at least. 1 boy and 1 girl. At least means minimum 1 boy and 1 girl should be there.
If we select
1 girl, we have to select the remaining 4 boys. Or if we select 2 girls, we have to select 3 boys. Or if we select 3 girls, we have to select 2 boys. Or if we select 4 girls, we have to select 1 boy. Here we have and. Therefore, number of ways is equal to 4C1 times 7C4 or 4C2 times 7C3 or 4C3 times 7C2 or 4C4 times 7C1. The first one is 140 and the second one is 210. The third one is 84 and the last one is 7. The total answer is 441. Third subdivision. 4 girls and 7 boys. And the third subdivision says at least 3 girls. Underline the word at least. At least 3 girls means minimum 3 girls. So we can select more than that also. So we may select 3 girls or 4 girls. We cannot select more than 4 because totally only 4 girls are there. If I select 3 girls, I need to select 2 boys. Or if I select 4 girls, I need to select 1 boy because totally we have to select 5 members. Therefore, number of ways is equal to, this is a selection question, combination question, 4C3 times 7C2 or 4C4 times 7C1. 4C3 is 4, 7C2, 6 and 7 by 2. 4C4 is 1 and 7. 84 plus 7 is 91. Example 22. Find the number of words with or without meaning which can be made using all the letters of the word again. If these words are written as in a dictionary, what will be the 50th word? We have 2 questions in this. The word given is again. It has 5 alphabets, out of which we have 2 A's. Find the number of words with or without meaning which can be made using all the letters of this word. So number of ways is equal to 5 factorial divided by 2 A's are there, so we need to divide by 2 factorial because number of permutations will reduce. 120 divided by 2, the answer is 60. The second question is, if these words are written as in a dictionary, what will be the 50th word? Let us arrange the words as in dictionary order. Let us count how many words we can form starting with the letter A. Remaining alphabets are G, A, I, N. So these remaining 4 alphabets can be arranged in 4 factorial ways, and all those 4 letters are different letters because one A has been fixed in the first position. Now out of those 4 letters we have only one A. So 4 factorial is 24. And then as in dictionary order, the next word will start with the letter G. And the remaining alphabets are A, I, N. In these 4 remaining alphabets, we have 2 A's. So number of permutations will be 4 factorial divided by 2 factorial because of these 2 A's. So 24 divided by 2, 12. We can form 12 words with or without meaning starting with the letter G. Then next, alphabetical order, I comes. The remaining alphabets are A, G, A, N. Out of these 4 alphabets, we have 2 A's. Therefore, number of arrangements will be 4 factorial by 2 factorial, which is again 12. This total comes to 48. 48 words are formed starting with the letters A, G, and I. Now, if I calculate the word starting with N, I will cross the 50th word. So let us list out the 49th and 50th word. So the 49th word is equal to, definitely it is going to start with the letter N, go in alphabetical order. So N, A, G, I. This is the 49th word. Let us write the 50th word. That also starts with N, A, I, G. Just interchange the last 2 letters. This is the 50th word. Example 23. How many numbers greater than 10 lakhs can be found by using the digits 1, 2, 0, 2, 4, 2, 4? We have 7 digits, 7 places. Okay. Now, if you form a 7-digit number, you cannot place 0 here. Other than 0, you can place any other digit. So it will be definitely greater than 10 lakhs. If you start with 0, it won't be greater than 10 lakhs. If you use the other digit in the first position, definitely it is going to be more than 10 lakhs. Let us calculate the total number of arrangements, including 0 in the first position. We have 7 digits given, which can be arranged in 7 factorial ways, divided by, we have 1, 2, 3 twos, identical items, and we have 4 2 times. So 7 factorial by 3 factorial times 2 factorial. This is total number of arrangement. Out of these total number of arrangements, how many numbers will start with 0? We will subtract these cases. So starting with 0, number of arrangements starting with 0 is equal to, if 0 is fixed in the first position, we have to arrange the remaining 6 digits, out of which we have 3 2s and 2 4s. We need to subtract these values. Therefore, the required number of numbers more than 10 lakhs is equal to, cancel 3 factorial, 4, 5, 6 and 7 by 2 factorial, minus cancel 3 factorial from 6 factorial, 4, 5 and 6 divided by 2. This is 420 and this is 60. The subtraction is 360. So we can form 360 numbers which are more than 10 lakhs using the given digits. Okay, example 24. In how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? We have a condition for boys. No 2 boys are sitting together. So we will arrange the girls first. 5 girls are there. 1, 2, 3, 4, 5. So 5 girls can be arranged in 5 factorial ways. This is an arrangement question, permutation question. 5 factorial is 120. Now see the remaining positions. Here we may put the boys in these gaps so that no 2 boys will be together. So we have 6 places, 1, 2, 3, 4, 5, 6, 6 possible places we have. But we have only 3 boys. So select out of these 6 places, select any 3 positions and put those 3 boys there. So no 2 boys will be together. So 3 boys can be arranged
in 3 out of those 6 positions
in 6p3 ways, which is equal to 6 factorial divided by 3 factorial. 4, 5 and 6. 120. Therefore, number of ways is equal to 120 times 120, which is 14400. This is an important question. Put a star in the textbook.